Hello, everybody. My name is Stepan, and I'm the product manager at anyLogistix, supply chain software. And today with me is Giuseppe, manager at National University Singapore. And we're going to talk about digital twins, supply chain digital twins, from concept to practice. And I'll be talking about concept, and Giuseppe will be talking about practice. Okay. So, a couple words about who I am. I represent the anyLogistix company, global software company. We're a world leader in simulation and optimization software tools, and we have two products. First is anyLogistix simulation modeling software, and the second one, which we are going to talk about, is anyLogistix supply chain analytics software. And here are some of our clients. There's a lot of clients from around the world, huge companies, including 40% of Fortune 100 companies. So what are we going to talk about today? Supply chain digital twins. And first, we'll begin with some definition of a digital twin and delve a little bit more about into simulation, the product, the technology underneath. Some examples of simulation and the concepts of digital twins and control towers. And then I pass it over to Giuseppe, who will cover his case study. So, what is a digital twin? There are numerous definitions to this term, and nobody knows which is right. If we look at Gartner, probably the most respected source of information about technology, they say that a digital twin is a digital representation of a real-world entity or system. And this is quite a broad definition, and it's hard to understand what they mean. Now, if you're just curious and go to Wikipedia, there will be numerous definitions and they'll be all different, but they have all something in common. What is this? So they all mention simulation, sensor updates, again, simulation, dynamics, some kind of real-time data, and understanding, learning, reasoning. And these are the words most often used to describe a digital twin. Simulation, real-time data, dynamic, and so on. So there's something about simulation, certainly. And how we as a simulation technology developer see digital twin and how our customers see it. A digital twin in supply chain is a detailed simulation model of a supply chain, of a logistics network, connected to some real-time data snapshot using some real-time data from operational systems. And the model provides supply chain dynamics forecast, which allows for understanding, learning, and reasoning. And this is a supply chain digital twin, which actually allows for taking midterm decisions, like simulating a few months of operations, and short-term decisions as well, more for kind of operational problems, low-level problems, which require you to simulate a few days or weeks. And what are the problems that you can solve with a digital twin? So there are various problems, and if we take a look at this pyramid, some high abstraction, high level problems with a low level of details are included in first place. For example, where to locate DCs or factories, where to stock products, supply chain master planning, to some medium level problems such as inventory sourcing policy planning and different other policies such as transportation policies or even risk analysis, to the lowest abstraction level where you model a very detailed thing such as a warehouse inside four walls or a factory inside four walls, and you can see how production planning process inside a factory can influence the whole supply chain. And this is something you can achieve with a digital twin. Now, to understand a little bit what a simulation is important, because simulation, as I said, is the technology underneath. Well, simulation is a computer representation of your real-world system. Like, for example, you want to model a supply chain that has a client, a DC or warehouse, a factory, and a supplier, and you set the rules of operation in a software tool. For example, a customer places orders for 300 units per day every 4 days, or no, 4 days a week, okay? And then a DC has some initial inventory, and if this inventory falls below some level, they order a batch or from a factory. If the factory has enough raw materials to start production, if they don't have, they order it from supplier. And if supplier workers are on strike, they will not process the orders. So this is the rules that you model, that you set, and then you have this model and can run a simulation. So this is modeling and this is simulation. You run the model to see the dynamics of it and to see how it performs over time. So for example, on day 1, customers orders 300 units, day 2, they order 300 units, day 3, day 4, the same. On day 5, the DC runs out of stock and they have to order another replenishment order, from the upstream. And the factory starts production. When the factory on the day 7 falls, raw material stock falls below a certain level, they order from a supplier. And this is how it works. You can see the whole thing in operation in dynamics. And this allows you to gather statistics over time. For example, you can see the inventory level that you see at every given day. And this allows for learning from the dynamics of supply chain and experimenting with what ifs. So dynamic simulation model, you represent how the actual rules of supply chain are structured, like actual supply chain, like inventory policies, sourcing policies, and so on, with randomness, with time, and so on. You are, as a supply chain specialist, conduct the modeling process and get the detailed results with stats like orders per day or inventory at each given day, lead time, and so on and so forth. This is simulation. And let's take a look a bit at the demo. This is the model, and we have different sites here. They're located in different places, and we have a structure view, and we can take a look at how supply chain is structured. This is suppliers, factories, DCs, so they're connected between each other, and these are ports that serve as cross docks in this model, and then DCs supply customers, right? And so we can look at the connections between them as well on the map, all right? So this is the supply chain that we have, and the data is defined in the tables. For example, we have our DCs that have certain policy parameters for inventory, like some certain reordering points and ordering rules with some initial stocks. We also have defined some facility expenses for storage. We have defined some products. We have defined some BOMs, how the products are produced, and so on and so forth. So demand is also defined. And we can run this simulation to see how the supply chain behaves over time. Now, let's see. We can see that something is moving, and these purple dots on the map represent shipments, and we see the model animation in the real time. And we see that we simulate 1 year of operations, and what's more interesting is that the stats are also changing dynamically. We can observe how they change. For example, this is revenue versus total cost, and we can see how they change over time. Also, profit and loss statement. So we can see how these things dynamically evolve over time, like inventory spend, inventory carrying cost, tariffs in different countries, transportation costs, production costs, and so on and so forth. And also, what's interesting is that we can see available inventory on a chart like this. For example, if we take a DC at Asunción and we want to know how much furniture they store, this is the line for them, and we can see how much furniture was stored at each given day. So taking a look at this, at such charts, we can understand what capacity the DC should have, for example, because if we see that the storage was not more than 350 units at any given day, then probably our warehouse should not be bigger. So I'll run the model a bit faster so that we complete the simulation. We can take a look at another example, which is a risk analysis thing. So we saw that it was quite a simple and deterministic model. But in the real life, we know that supply chains are subject to risks. Who knows it better than people who manage disaster management logistics, yeah? So this is quite obvious that we have random events and they influence how our supply chain behaves. So in this example, we'll see how it works. For example, we have a factory in Vietnam and we have a port which serves as a cross dock, and they supply certain number of DCs and customers in Japan. And we have defined the model, but what we have here in addition to what I already showed to you is random events. For example, we have a certain probability that a rainy season in Vietnam may impede the production and stop factory from producing. So just randomly, let me set it for 50%, yeah? And with the end of raining season, for sure the production will be restored. We can also see that with certain probabilities, 80 and 90%, there can be increase in or decrease in demand. And we also take into account the probability of factory failure of 50%. So it can fail randomly throughout the year, and it will recover for 7 days. So let's run the risk analysis experiment and see how these random events might impact our supply chain. So we're running this scenario for 30 times, and in certain runs, the random events will occur. In certain runs, they will not occur, and there will not be risks. So we understand this way how risks affect the performance of the supply chain. So we run the simulation, and we have this best, mean, worst graph. Our target metric to optimize is service level here, and we can see that in the best scenario, the service level was always 1. In the mean scenario, it was falling due to some disruptions, and in the worst scenario, it was even falling down to 0 with no recovery until the end of the simulation, which is not a good thing. So we also have data for events and recovery. So we see that in certain number of events, like in 14 replication, there was no failure, so everything went all right. In 13 runs, there was a disruption, but there was no recovery, so the supply chain wasn't able to recover until the end of the simulation. And in one case, it was able to recover. So this way, we can see that probably we need to increase some resilience or robustness of our supply chain, and probably add some alternative suppliers or alternative factories where we can produce goods, so that nothing is impeded so seriously. Okay, so getting back to the slides. Can you see the slides now? Yeah?
Yes.
Okay. Have a little more to say about digital twins. So we say, I just show you simulation, but for sure, this is not the only thing that can be included into a digital twin. It also can leverage optimization and even AI technologies. How can it work here? So simulation is giving you forecasts. It doesn't give you like directions what to do, where to go. For this, you can use optimization. So how does it work? For example, you run the forecast, you run the simulation. On day one, the forecast is okay. Day two is okay again. Day three and day four, an unexpected event happens. Hurricane destroys DC network. So we have to rearrange our supply chain so that it recovers. And we can run an optimization which can suggest you an adjusted supply chain structure with different DCs selected. And this suggested structure can be fed back into the digital twin, and it can keep forecasting, and this will allow you to restructure your supply chain on the fly. So yeah, for sure, optimization and even AI can be in place of optimization here, can be a part of a digital twin. Now, if we say that a simulation model is a digital twin, this is quite a narrow definition. Usually, simulation model is a part of something bigger to make it a digital twin. Now, what it has to do? What makes a model a digital twin? First, it's a detailed model. It's not just some model. It has to be able to predict the behavior of your supply chain in details and with really preciseness, with high preciseness. It has to use some real-time data snapshot, has to be connected to data from your operational systems, such as ERP systems, like SAP, for example, or supply chain management systems. And it has to be able to provide you with notifications and alerts when something abnormal happens. Like, for example, if the forecast shows you that we'll be running out of stock soon, you'll have to be able to receive these alerts to make changes to the structure, to test some what-if scenarios and make the changes required. Triggers, again, some if-then actions, like if the disruption occurs, run the optimization, just as I showed in the previous slide. Test and action plan, for sure, you have to be able to run what-if scenarios with the digital twin, like change parameters in the model, run it again, see how the changes affect the situation, and connection to the IT infrastructure of the company or the organization. Because in many cases, the digital twin is part of some bigger thing, like a control tower, which I'll show later, which allows you to integrate your model with some real-time data. Now, how usually a digital twin is structured? First, this is the IT infrastructure that I mentioned. The systems that store operational data of the supply chain, like ERP, like SAP, or supply chain management systems, or manufacturing management systems, warehouse management systems. So they all store the current state of the supply chain. Now, if you feed this data into a model built in anyLogistix, you can make a forecast based on the current data. And you can conduct different kinds of experiments like what-ifs, optimization, risk analysis that I showed you, simulation, and so on. And users and stakeholders can do it. And what is more, anyLogistix can connect to some business intelligence tools such as Power BI or Tableau that are sometimes more convenient to use than built-in visualizations for managers and stakeholders in the organization. So they can host this BI dashboards on their company service and like connect to them through a browser. And yeah, the control tower is a concept that people and clients are asking about more and more is a central hub, a central repository for management inside a company. Yeah, it's not only for supply chain, it's for everything. So it has two main modules. First is these dashboards, business intelligence dashboards and visualizations. And second is the data underneath. So it has three pillars. First is the current state of the supply chain. And this is the operational tools that I mentioned that people are using for managing supply chains day to day, such as SAP. Second is the forecasting model, the decision support module. And this is the digital twin. Some model built in anyLogistix connected to this operational systems. So it can be a supply chain digital twin. People can also build manufacturing digital twin, financial digital twin, so on and so forth. So it's not only limited to supply chains, but we are talking about here supply chains, yeah. And the third part is the task and case management, is some project management tools maybe, or task management, where stakeholders and managers assign certain actions to some responsible people who take responsibility of the changes required to operate our network, our company. Yeah, and basically this decision support module is where anyLogistix fits in as the tool that allows you to integrate your real-time data with a simulation model, forecasting. It enables you to model, design, and analyze your supply chain. And what's unique about anyLogistix is that it leverages two analytics engines. First is dynamic simulation, which uses anyLogic engine underneath, and anyLogic is the worldwide leader in simulation. And second is optimization techniques by IBM Ciplex, which is also the top solver in the LP world. And the combination of both makes anyLogistix a very flexible tool that allows you to model your supply chain in much details and capture all the special traits of your logistics network. Now on to the case study. I shall pass it over to Giuseppe.